Right now, what we know about isosceles is that they have two equal sides. That's all we know about them. But what we're going to learn more today is about them also having two equal angles. So however many sides match, that's how many angles will match. You have two equal sides, you have two equal angles. Same thing with equilateral. If you have three equal sides, then you have three equal angles. Okay, so we talked about this before. This is the vertex angle. I talked about that on Friday. The vertex angle is the included angle. So it's the angle that's included between the two congruent sides. Okay, so the other two angles are going to be, what do we call it? We call them base angles. Okay, so these two are going to be equal to each other. So the easiest way to do it, find your vertical angle. The other two are going to be equal. Equilateral triangles, you need to think about. We already know that three equal sides have three equal angles. And do we remember what each one was? 60. Okay, so those are the two things we're going to be working with a little extra today. So here are my problems. Some of them, like this, most of them are going to have X's in them and you're going to be solving. This one says, if AC, so this side right here, is congruent to AD, which is this side right here, it says name two congruent angles. So this would be the rest of my triangle. So in this purple triangle, if these two sides are equal, that would make this the vertex angle, which would make angle C and angle D congruent. Now in this particular case, since there's more than one angle at C, you're going to have to say angle ACD. But you can say angle D. If you want to use three letters, it's nothing wrong with three letters. When in doubt, use three letters. It could be anything like CDE or CDA. I'll just say angle D. It's the only angle at angle D. That's why I'm allowed to do that. Okay? So that's the first one. That's kind of what you're doing. So if you want to pause me and see if you can try the rest, go ahead and try them. BE and BC are congruent. They want to know the two congruent angles. So if I complete my triangle, here's what it looks like. They said those were the equal sides, so this is the vertex angle, which means these would be your two equal angles. Both of them need three letters. You have to have them or you're losing points for them. Probably most, if not all, points if you don't use three letters for these ones. So that one's BCE. And the lower one down here at E is BEC. You can go the other way and say CEB though, it doesn't matter. All right, next, I've got angle EBA. So if I do EBA, if I look at EBA, that's this angle, is congruent to EAB. That's this angle. Okay, remember the letter in the middle, that's always going to be your angle that you're really looking at. It's going to be the vertex. So if those two are equal, they want the two congruent sides that are equal. Okay, so if those are the two, this is the vertex angle, which makes these the two equal sides. So you would be saying segment BE, make sure you have your notation, and segment AE. Okay, notation I'm looking for, congruent sign I'm looking for. Okay, and then 4. So in number 4, I've got angle CED. So CED, if I highlight it, CED is this angle. And CDE is that angle. Name the two congruent segments. That would make this the vertex angle. So those are your two congruent sides. So segment CD and segment CE. Okay. Next. Now we start to get with the numbers and the degrees. It says ABF right here is isosceles. They marked it for you. CDF, so CDF right here is equilateral. I would go ahead and mark that, which means also since it's equilateral, I will also mark all my angles equal. And if all of my angles are equal, they are all 60. When you see directions, I would definitely recommend that you write stuff in. And then it also says AFD, measure of angle AFD is 150. So AFD is 150. This one is a little harder to mark. So I'm going to do it because I have color and you can see it. But if you have pencil, it's going to be a little harder. So that's going to be 150, that green one. Now we're going to go ahead and figure out all these. So CFD, if I look at CFD, I already got it marked, 60 degrees. Okay, ABF, I'm looking for this one. And 7, I should probably do 6 before I do 7 because right now I can't find that one. So I need to find something else. So in number 6, it says AFB. So AFB, that's this one right here. The way I'm going to find that is I'm going to use the green angle because the green angle is 150. So if I take away this part and this part, I'll be left with the one I want. So I'm going to take the 150, subtract the 60 and the 35, and that's going to leave me with 55. $80, $90, yes. Okay, so now that I have that one, I can find number 7. So look at number 7. It wants ABF, which is the one with this question mark up here. So if I want that, I know I only have one of the angles, but if I have 2 equal sides, that means I have 2 equal angles. So this one's also 55. Now I can find the question mark. So 3 angles in a triangle add up to 180. So I'm going to take 180, subtract 55 and 55. So that's going to leave me with 70 for number 7. And number 8's nice and easy. Angle A, measure of angle A, we already got 55. Okay. All right, next, in the figure, PL is congruent to RL. And LR, which is the same thing, is also congruent to BR. So LR and RL are the exact same thing. So since they're equal, you just mark them all with one little mark like that. Okay, now it says if RLP, so RLP right there is 100 degrees. It says find BRL. So BRL is this one right here. It's hard to make a question mark that small. All right, so to find that, first of all, if this is 100, I know with this being my vertex angle, this is my vertex angle. So if that's my vertex angle, these two will be equal. I have no idea what they are, but I know that the 3 here will add up to 180. So if I take 180 and minus that vertex angle of 100, I'm left with 80, and I got to split it into 2 equal parts. So if I split that in 2, that's going to give me 40 for each of these. Okay, technically you can make an equation and say x plus 100 equals 180 and then solve for x and get 40, that's fine. But this is still not answering my question right here. I want this one. So I need to figure out what that is. So to figure out what that is, what I have to do is I'm going to use this 100 right here. So this 100 and this angle, these two make a straight line. They're a linear pair, so they add up to 180. So when I did the 180 minus 100, I got 8. This question is the vertex angle, which would make this also 80. These would be my 2 equal angles. 2 equal sides, 2 equal angles. So now to find that question mark, 3 angles in a triangle add up to 180. Now I got to minus both of them. Sorry, I didn't mean that line. So 180 minus 80 is 20. That's the one we're looking for. Okay. Now, LPR, so they're doing something different now. So my purple stuff can stay, but everything else has got to go. Because that purple stuff right there, that was all in the directions, the original directions. So that went with both pictures. So now it says if LPR, so LPR is 34, they want you to find angle B. It's basically going to be the same thing. So if this is 34, this is 34. So I'm going to minus these two from 180 because 3 angles in a triangle add up to 180. And that's going to give me 112. And then I'm going to find B the same way I was doing the other way. So on this one, those two at the vertex L add up to 180. So if I do 180 minus that 112, that's going to leave me with 68. So this is 68. which, like we said, this was the vertex angle, so this will also be 68. Okay. Okay, a bunch of examples down here. So this is a ton of examples. The only one that's different is probably this last one, this classify one. So if you totally get it, have no problem. If you want to skip ahead, you can. So I'm going to go through these kind of quickly. So this one up here, 3 equal sides means 3 equal angles. So you can either make them all 6 x's and add them to equal to 180, or we also said if they're all equal, each one equals 60. So if I do that and divide by 6, x is 10. That's all they want in the directions, so I'm good to go. Over here, equal angles mean all equal sides. So I can set those two equal to each other. If I subtract the 6x, I get negative 1x. So bring down my negative 5, divide by negative 1, x is 5. Okay, over here, right here I have 2 equal sides, which means I have 2 equal angles here and here. This one's 60. So if I do 180 minus 60, I get 120. And if I have to split that into 2 equal angles and divide by 2, I still get 60. So it actually is equal angular and equilateral. So all of these sides are equal, which means these two are equal. So if I minus the 3x and add the 4, there's x. Okay, down here, 2 equal sides. This is your vertical angle. So that means this will also be 2x. I have 2 equal angles. That's going to help me solve. So add them up, set them equal to 180. So this gives me 4x. Subtract the 40, divide by 4. So x is 35. Okay, next. If these two angles are equal, that makes this the vertex angle. So these are my 2 sides that are equal. If those equal, set them equal. So if these 2 things are equal to each other, subtract the 2x from the 3x to get 1x, add 6 to 6 to get 12. All right, and then over here, 2 equal sides, this is the vertex angle. So I know that these 2 will be equal. Over here, here's my angles. This again is the vertex angle. So if I have 2 equal sides, I'm going to have 2 equal angles like this. Okay, the way we're going to do this is we're going to use the 2x because this is a vertical angle. So if you have a vertical angle, then that one's equal. We cannot find P and Q. We cannot find them. It's impossible. You could do 2x plus x plus x, but it would have to be a different letter. And so that would make it pretty difficult. Okay, so in this case, I'm going to use the vertical angle and use the 2x. I know that those are equal to each other. So this one is 6x and 6. This one is 6x and 6. So my equation, I'm going to add all 3 of those. That's supposed to be an x. So I add all 3 angles, set them equal to 180, and then I'm going to solve. So 6x, 6x, and 2x is going to be 14x. I got 6 and 6, which is 12. I'm going to subtract that 12 from the 180, which is going to give me 168. And then I'm going to divide by 14, which is 12. Okay. Next, 7. On 7, 2 equal sides. This is my vertical angle, or my vertex angle, I'm sorry. So that would make these 2 equal. So this will also be 3x. Okay, and then they gave you this little mark. So see these 2? They're telling you these 2 are equal. So since we figured out that's 3x, this is also 3x. So now I'm not going to bother with this vertex angle up here. I have no idea what it is, nor can I figure it out. But I have 3 angles in a triangle right here. So I've got 3x, I've got 30 and 90. 3 angles in a triangle add up to 180. So 30 and 90 is 120. Subtract it from 180. And then divide by 3. Okay, over here, isosceles, 2 equal sides means 2 equal angles. This is my vertex angle. So then that makes these 2 equal. So if that one's x, that one's x. So add them up. I got the 3x, the x, and the x equal to 180. So I add all 3 of these, and I'm going to get 5x equals 180. Okay, divide by 5, and you get 36. Okay, down here, same thing every time. I'm just giving you a whole bunch of examples. So if I've got 2 equal sides, this is my vertex angle. My 2 equal angles are here and here. So if that one's 3x and 8, that one's 3x and 8. So add all 3 of them. Set them equal to 180. 3 angles in a triangle add up to 180. 3, 3, and 2 is going to give you 8. 8, 8, and 20 is 36. If I subtract 36 from both sides, no. I'm going to get 144. Okay, and then divide by 8. And that's going to be 18. Okay, if they ask you to find the measure of all 3 angles, you just need to plug that 18 in. The very last one that we're doing today is going to be classifying it. So classify, remember when it says the word classify, that's when you're going to use your words. So that's when we're going to be using isosceles or scalene. So we're looking for sides. So it's either isosceles, scalene, or equilateral. So to be able to do that, here's what you need to do. We can't find the distance between 2 points if the line is diagonal. You can if it's vertical or horizontal. So if it's vertical or horizontal, you can just count the spots as units. 1, 2, 3, 4. Nice and easy. The other two, the only way you can find the distance between 2 points if it's diagonal is, yay, the distance formula. So you got to do x2 minus x1 squared. And then y2 minus y1 squared. So you got to find your coordinates. A is 0, 0. B is 2, 3. So you'd have to find the length of from A to B. You have to use those, plug them in, find out what your side length is. And then you use B and C, which is 4, 0. So use B and C to find the length of BC. So when you plug those into your formula, your distance formula, AB, I plugged in 0, 0 and 2, 3, got 3.6. BC, I plugged in 2, 3 and 4, 0, and also got 3.6. So I've got 4, 3.6, and 3.6. So I've got 2 equal sides. If you have 2 equal sides for that one, this one is going to be scalene. Please do not just go by looks. It's going to be hard to tell. This kind of looks like all 3 might be equal. So make sure you plug it into your formula and find it.